All right, let's take a look at this. This is it's a weird name, piecewise functions. Okay, it's because the graph is kind of broken up into pieces. That's basically what it is. Up to this point, we have been good with just straight lines. Every once in a while, like on that quiz, remember we just put the dots on there, right? Because it just included the integers. But I don't know if we consider that a piecewise function. Maybe you kind of could. Oops, wait a minute. I don't want that. I want to do red. But basically, for the most part, everything we've done so far is like that. Okay, it's continuous. All right, we'll say that. Except, again, for that one graph that we did with just the points because it was just the integers. All right, but for the most part, every graph that we've done up to this point, even in Algebra 2, until you did this lesson, you probably did this in Algebra 2 is my guess. But it doesn't matter. I'm going to teach it anyway. But they're continuous functions. Well, this is not going to be a continuous function. It's going to be a function that's broken up into different pieces, as we said. And how is this applicable to real-world situations? Well, they give a little example in here, and I'm not going to get super detailed with it, but I will talk about it just so you can see. And this graph probably makes a lot of sense to you. Okay, you've probably seen graphs like this before. All right, and we got this is distance, this is time. All right, and I'm not gonna get really super accurate with it. So we'll say that that's 246. This is in miles. I'm gonna put that under here. All right, so this is distance in miles, and this is time in minutes. All right, and let's see, I go by fives on this one. 5, 10, 15, 20, 30. Okay, that's good enough. So there's 5, 10, 15, 20, 25, and 30. So this is basically a graph describing a bus route, okay? So you get on a bus, you go a certain miles, you stop for a certain amount of time, then you keep going for a certain amount of miles. You stop again at another bus stop for a little while, then you keep going. All right, so this is basically what it is. So they say you go 30 miles per hour for 8 minutes. We're not going to worry about the slopes and all that kind of stuff on this. This is just to give you a general idea of what a piecewise function could look like. All right, so let's see. We went for 8 minutes. So it went from there, and we again, I don't really care that this is accurate. All right, so like you went to here. I'm not even going to use the numbers they do. So this is how much time you went. This is the distance that you traveled. All right, but then if it's a bus route, what do they always do? They stop for a while. So what's my line going to look like if I stop? That means the time is, well, the time keeps going, but the miles is what? Is flat, right, exactly. Everybody see that? So that represents, you're sitting there, the clock's still ticking, but you haven't gone anywhere, all right? And then, what do? You might speed up, all right? Or let's say you go slower. We'll make that, okay? That slope represents your speed, your velocity, right? You go a little slower because you're in a development now, and then you stop, and then you're at the bus stop, and you stop for that amount of time. And then maybe it goes down. What would the down indicate?
Down.
You made it back. That's right, because you started here, you went these certain miles, and you made it back. Okay? So these are different pieces. All right, let's make these different colors. Make that. Let's make it light blue. We'll make this a color. And these are your different pieces of your graph. Okay? So this could be considered a piecewise function. So not every graph that you ever graph, and actually tell you the truth, a lot of graphs in real life situations hardly ever go in a nice, straight, perfect line. All right? There's always some kind of variables that affect it. Right? Stopping, going faster, going slower, different things like that. So they don't always go in a nice straight line. We learn that at the beginning when we do graphing because that's the easiest way to learn it. But then it gets harder and harder and harder. There's all kinds of crazy stuff. You've probably seen all kinds of graphs, right? Like financial graphs, right? Where, from year to year to year. Well, again, I'm not getting political here, but a graph actually saved Donald Trump's life. Okay, do you know why? Because he had a graph of the immigration on this big screen, and he was talking like this, but then he turned. Which way did he turn? This way? Yeah. He turned this way, and he said, "Look at my great, fantastic, best ever graph in the world," right? And he turns like that, and the bullet hits him in the ear. If he would have been like this, it would have hit him right in the middle of his head. All right, but the graph, and he jokingly says that graph saved my life. All right, and so again, I'm not being political or anything. I'm just saying, we saw that on TV. Everybody's seen it, and that graph. If you look at the graph, it would go like up and down, squiggle, squiggle, squiggle. Right? It might go squiggle, 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 right, for a while, and then it went like way up like this, and then, according to him, again, I'm not being political, but according to him, like, immigration went way down during his years, and then it rose up again for the other years, So you see that all the time. Everywhere you see it, all right? And those are all piecewise functions, all right? Because it's not just one continuous, just straight up that way or straight down that way. There's always little alterations, right? Little changes going up and down. Make sense? All right, so that's kind of what we're doing, kind of. So what we're going to do is I'll graph a piecewise function for you. I'll show you what the equation is, and you'll see what one piecewise function is. We're going to actually do, well, this one's just some kind of random function. Then we're going to do one called a step function. You guys remember doing step functions where it kind of looks like a ladder? It looked like steps, like boom, 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 boom. I bet you. I thought somebody said that they had done that before. Okay, maybe when you see it. And then we're going to graph absolute value. Have you graphed absolute value before? Yeah, you've probably done that. This probably should not be brand new to you. Maybe some of the words that we use might be something you hadn't heard before, but for the most part, this is what we're doing. All right, so here's example 1. And it says to graph this. So f of x is basically just the same as saying what? Y equals, right. But nowadays, we're getting a little smarter, and so we say f of x. So here it is. So y equals 1. What would that look like? Y equals 1. What kind of line does that look like? Straight through? Give me a better description. Y equals? That's the only other choice, right? All right, so it's a horizontal line that goes through what? 1 on the y-axis. We just finished doing a problem like that, okay? I thought you would have that down by now. All right, so now here's what you're going to do. They're going to give you restrictions. They're not just going to say graph y equals 1. If I did that, it would be continuous. It would keep on going forever in both directions, a horizontal line going through 1. But they give you restrictions here. They say that x, it's kind of like changing your domain, all right? X is less than or equal to -2. So we're going to graph that. We're going to graph 3 different graphs on the same x and y axis, on the same graph, okay? And then we're going to graph x plus 2. You should know what that looks like. Y equals x plus 2. What's that going to look like? Well, you're going to go up to 2 on the y-axis, right? That's the y-intercept. And you're going to rise 1, run 1, right? But you can only go from, it's not going to be a line that keeps on going forever and ever. You're restricted. And they say that x is going to be between -2 and 3. And it is going to include 3 because it's or equal to. And you got one more. F of x equals 2x if x is greater than 3. All right. Let me grab a graph here. I'll get back to that, don't worry. I'll grab this one so I can be kind of specific. Oops. What do I want to do? Oh, that one. If I can remember how to do this, hit shift, click. Where is it? Why isn't it doing that? Hold on. Why isn't it? Did I do something? Let's try it again. I should be able to grab that corner and make it bigger. Why is it not working? I have no idea. It's acting super weird. Maybe, is that V? Okay, let's try it again. Oh, there it goes. I don't know. I think I know what I did. Hit some other button. All right. We'll try to make it kind of big. I think we can fit everything in here. Yeah, because we're just going to -2 to 3, right? So it should be pretty easy. Okay, so let's do this. Let's do it in red so I can see it. All right, let's do this one. Y equals, f of x equals, y equals 1. So it's going to be a horizontal line, but what's my restriction? I can only use the points that are less than or equal to -2 on the x-axis. So if I was to graph this, y equals 1, it would be right here. And watch. I'm going to make the regular graph, but then I'm going to shorten it up and use our restriction. So if I just said graph y equals 1, that's what it would look like right there, wouldn't it? But I have restrictions. I can only use the points that are what? So x can only be less than what? Or equal to -2. So can I use any of these points out here? No. Where am I going to have to take it to? No. X can only be to start there. Do you see that? So I can't use any of these x points way out here. I can only use the x point from -2 to the left. Got a lot of people that are napping. You better wake up. I know it's the end of the day. I get it. The worst time ever to have pre-calculus. I understand. But you got to wake up. So that's part of it. That's 1/3 of our graph right there. Everybody see it? We have restrictions. So we said x can only be from -2 to the left, less than -2. So we took that line, we shortened it because of our domain restriction. Okay? Let's graph another one. Let's make this a different color. Let's graph x is equal to x plus 2. So if it was just y equals x plus 2 and no restrictions, what would it look like? Y-intercept at 2, and what's my slope? 1/1, right? Or this way, 1/1. And then it would look like this. Right there. And it would look like this. Right? Down to there. Pretty close. But we have restrictions, though, on the x. I can't just keep on going forever in both directions because they restricted me. X can only be between what? -2 and 3. So where's -2? Right there. So this line this line can only go to there. Right? There's my -2. And what kind, is it going to be closed or open? It's going to be open because it says it's just x is greater than -2. And x can't go any further than where? +3. 1, 2, 3. That means I'm going to stop it right here. So I put that right there. And it's closed because x could be equal to 3. So that's what this is right here. So it's a little different. You're so used to just putting a long line with arrows on both ends, keeps on going forever. But this one, they give you restrictions. X can only be between -2 and 3. It can't be equal to -2, but it can be equal to +3. So that's part of it. What's another one? Let's do a different color. Let's go green. So y equals 2x. How do we graph that? Well, we would put a y-intercept right here, wouldn't we? Don't worry about the restriction just yet. Let's just do y equals 2x. Y equals 2x. It's y equals 2x plus what? 0. So the y-intercept is 0. What's the slope? It's 2. 2/1. I'm going to do that a couple times. Is that all right? A few times. Just so that I can make my straight line. Did I do that right? 2/1, 2/1, 2/1, 2/1. Yep. So watch this. I'm going to go from there to there. And that would go from there to there. If I kept it going. All right, but I'm going to restrict it though. That's what it would be, and I put arrows at both ends. That's what y equals 2x would be. Yes? All right. You guys are acting like you're coming off a sugar high or something. When you first came in here, everybody's bouncing off the walls. Now, everybody's like dead. I know, it's a little warm, and it's late, but let's watch. Come on. X is greater than 3. So what points can I pick? So I go to 3. 1, 2, 3. I go all the way up to here. So see this point right here? That's actually going to be, get rid of. That's actually going to be open. And then it's going to go where? Way up here like that. But all this other stuff I'm not going to use, because that's not within my restriction. Okay, my restriction is right there. And that's my graph. That's how I graph these three things. And these dots, these points, I can get rid of. I just use those for guidelines. There you go. So that's your graph. All right, it's kind of weird. It's 3 graphs, but it's all put on one piece of graph paper, and we have restrictions on here. Do you understand what the x's are doing? They're making it so x can't be way down here, because x can only be equal to or greater than 3. So I can only pick x's that are bigger than 3. All right, so my graph did go all the way down here like this, all right, but I'm restricted on the x values. So it can't go all the way down here because I can't use any values that are less than 3. Are we getting this or not? I don't know. I can't tell from your faces. I have a feeling this is stumping you. What is stumping you? The x thing? It's got to be the x thing, right? Well, the slope is 1. Okay, because look. Here, let me write it like this. Y equals 1. Let's make it all white this time. Okay. So we got 3 equations. There's the first one. What's the second one? Y equals x plus 2. What's the third one? Y equals 2x. So what I did is I just graphed these with no restrictions at first. Okay? I put the whole entire line on there. Everybody see that? But this y equals 1, I can't go all the way to here. I'm restricted. The x can only be from -2 all the way to the left. So where do I go on this graph? See that graph? I go on the x direction to -2, which is right here. So I can only pick this point and everything to the left. You get that? Yeah, I get it. Okay. This one right here, y equals x plus 2. What's the slope of this? X. No, it's 1. All right? So that's the blue one, right? So what did I do? I put a 2, right, at the y-intercept, and I rise 1, run 1. Or I rise -1, run -1. Right? At first, I put the whole entire line there. But I can't use the whole entire line because of this. They restrict me. X can only be between -2 and 3. So on this line, where is x equal -2? It's right here, isn't it? And where is x equals 3 on that blue line? 1, 2, 3, right here. See how on the x-axis I went over 1, 2, 3? So this says I can only use the points between -2 and 3. I can't use the -2, so it's open, but I can use the 3 because it's or equal to, so I close it in. Did the same thing with the green. At first, I graphed y equals 2x. So it's y equals 2x plus what? 0. So I put the y-intercept right here, and I graphed it. I went up 2 over 1, up 2 over 1, and I made my graph. The thing is, I can't use the whole entire graph. Why not? Because they're restricting me. They're telling me I can only use the points on the x-axis that are greater than 3. So look, I took that green graph, I went over 1, 2, 3, right, on the x-axis. I put an open circle. Why did I put open? Because this is not or equal to, it's just greater than. And so I can only pick the points to the right of +3. And that's why it's short. Okay, that's why it starts here and it keeps on going. This one, it stops here and it stops here. Well, it stops right before this. This one keeps going forever in that direction. because it's not in between two numbers. Man, I'm knocking you out. I got people with their heads down all over the place. All right. You can go watch the video again. If not, look, this is what I do. If I don't understand something, you know what I do? What do? Do I call up Mr. Rao? Mr. Rao, please help me. Why'd you leave me? I can't ask you any questions. Well, I could go to Khan, but I go to YouTube. Exactly. Okay, I go to YouTube. And I just put it in. I just type it in. Piecewise functions. Okay? I just put in piecewise functions. And there are going to be so many YouTube videos. If you don't do that, you're not really that concerned about your grade. All right. Tell you what, I'm going to, since due to time, I didn't think that would take that long. I thought you would get that right away. Let's skip to the absolute value, then I'll go back to the step. When we have time, we'll do the step, but that's going to take a little bit of extra time. I'm going to skip to the absolute value functions. They're a little easier, I think. The step functions, I think out of all the ones we do today, or in this lesson, I think the step function is a little harder to understand, all right? So let's do absolute value. We're going to graph absolute value. Absolute value. You know what absolute value is, right? So if I have the absolute value of -3, what's the absolute value of -3? It's +3. What's the absolute value of +5? It's +5. Absolute value is always positive, okay? You with me? So what we're going to do is we're going to graph f of x equals the absolute value of x. Or if you like to see y, I'll put the y in there just so you can see it. But the f of x basically means the same thing. But don't get used to the y, because a lot of times they do these functions, they ask you to do stuff and graph stuff. They're going to be putting f of x. So we got to get used to it pretty soon. But for right now, I'll just let you put y equals. Okay? That's what we're going to graph. Remember when you first did graphing in Algebra 1? What did they teach you to do? That little table. Do you remember that? And then you put an x, put a y. Then you put some numbers in, put it into your function. We didn't call it functions back then. We just called it an equation. You just put it into the equation. You figure out what the y is. You plot the points, and boom, you got your graph. That's basically what we're going to do right now. Now, I'm going to put some negatives in there. I'll put 0. I'll put some positives. Let's just go -3. -3, -2, -1, 0, 1, 2, 3. This should be really easy. What are we doing to it? What are we doing to that -3? We're taking the what? The absolute value of it. So what's the absolute value of -3? +3. What's this going to be? Then 1, 0. What's that going to be? Positive or negative? Positive. And then 2, 3. So this is what we're going to graph. Okay? Everybody with me? That was easy. So let's graph this thing. I'll go red. So -3, 3. Put a point. 1, 2, 3. 1, 2, 3. -2, 2. -1, 1. 0, 0. 1, 1. 2, 2. 3, 3. Look what it looks like. It's not just a straight line in one direction, is it? Right? But these lines, now we're not just taking the integers this time, and we're talking about all the real numbers, okay? So we do put a line. So I'm going to start here and go like that. And then I'm going to start here and go like that. And it keeps going forever and ever, right? Because I could have started at infinity, couldn't I? And negative infinity. All right, so it keeps on going forever. So that's your basic absolute value graph. It looks like a V. Value, absolute value. Looks like a V. All right, that's how students can remember that. Now we're going to be learning some stuff, and I'm sure you learned it in Algebra 2, where you shift the graph over, right? You shift it up and down and left and right and all that kind of stuff. So that's what we're going to do. So I want you to see what happens. I think I'm just going to erase this so that I can keep that graph right there. So you can see the difference. And I'm going to scooch this over a little bit. So now what I'm going to do is I'm going to graph this. So this one doesn't say the absolute value of x, because that's a real basic one. Watch what it does. It's 2 times the absolute value of x minus 6. That's what we're going to graph now. Okay? So, if you remember, I don't know if you do or not, but if you remember, this, when you subtract something, it shifts it down. All right? If it was plus something, it would take the exact same graph and shift it up. Do you remember that in algebra? Algebra 2? Yeah? And then there's another thing. You can move it left and right. We're not going to do that right now, okay? But there's another way you could do it if you moved it left or right. But right now, that minus 6 means this point right here is going to be at negative 6. So how do I know that? Let's do a little chart so we can see it. So I'm going to do the negative 3 again. Let's do the same thing. Negative 3, negative 2, negative 1, 0, 1, 2, 3. Now, they haven't taught you yet in this book how to shift it left and right and how to shift it up and down. All right? They will eventually. All right? Probably pretty soon is my guess. Let's put some points in here. Now, we got to do a little bit extra math. All right? So if I put a negative 3 in for the x, well, you take the absolute value of negative 3, which is 3. 3 times 2 is 6. 6 minus 6 is 0. Okay? Then let's put the negative 2 in there. You'll eventually see a pattern. We don't have to do the math every single time. Okay? Put a negative 2 in for x. So what's the absolute value of negative 2? 2 times 2 is 4 minus 6 is negative 2. See that? And then put the negative 1 in there. That's a 1. Absolute value is 1 times 2 is 2. 2 minus 6 is negative 4. What do you think it's doing?
By 2.
It's going by 2s. That's right. Well, let's think about this, though, because look, if I put a 1 in, it would be the same thing as if I put a negative 1 in, right? Because the absolute value of negative 1 and the absolute value of positive 1 is the same thing. So it goes the other way now. See that? Negative 4, and then what? Negative 2 and 0. Okay? So let's plot. Oops, what did I just do? Oh, I think it still works. Click something. Let's go blue. Blue's always my second choice. All right, so let's plot that. So negative 3, 0, 1, 2, 3, 0. Negative 2, 2. Negative 2, negative 2, sorry. Negative 2, negative 2. See what we're doing? And then what? Negative 1, negative 4, right there. 0, negative 6. And then the other side is going to be the same exact thing, isn't it? See that? See this? And there you go. There's your 3, 0. So let's take a look and compare the two. The red one is just your normal, everyday, plain Jane, y equals absolute value of x. But this one, we did a couple things to it. There we go. So look what happened. Talk about the shifting, moving it up and down. Where did we move it? We moved it what? We took that red one and moved it down, didn't we? How far did we move it down? 6. We moved it down 6. There's that negative 6. So what does this tell you to do? This tells you that you move it what? You move it negative 6, or down. In this case, it's down because it's negative. You move it down 6. That's what that thing on the outside tells you. So what if you put a plus 6? You would have taken that red one and moved it where? Up 6. Okay? We're not going to worry about the left and right now. Look at what the 2 did. What do you think the 2 did to it? Okay, made it skinnier. Good. Or it made the slope of it what? Steeper. Okay? It made the slope of it steeper. Because what's the slope when it was just y equals absolute value of x? What's the slope of it? It's 1. This time it's 2. So what's it going to do? It's going to be steeper, right? So instead of going up 1 over 1, it's going to go up 2 over 1, which makes it steeper. Okay? Does that make sense?
Yeah.
So that's the kind of stuff that you're going to see later on. But they call these piecewise. Why are these piecewise functions? Because it's not just one continuous graph, right? It's not just one continuous graph. It comes down, well, it starts here, it goes in this way, this way. You see how it's broken up into basically 2 different pieces? That's why it's called a piecewise function. I thought I'd have time to do everything today, but that step function takes more than just 5 minutes, and that's all we have left anyway. So it's really not that hard once you understand it, but it definitely looks kind of weird, all right, compared to what we've done. This doesn't look super weird because you've got straight lines and all that kind of stuff. The thing over here didn't look, well, it does look weird, but it doesn't look super weird because they're straight lines. And the thing we're going to do next has straight lines, but it's just a lot different, okay? So we'll talk about that. It's called the greatest integer function. Do you remember doing anything with the greatest integer function? No? Maybe one day I'm going to say, do you remember doing this in Algebra 2? And you're going to say, oh yeah, I did that. Hasn't happened much this year, has it? All right.
It really hasn't happened. Like, that's why we're so cooking AP by right now. Because we're supposed to know like a lot of stuff.
Right. Right. Well, hopefully you'll know this stuff when you get to your next level math class, I hope. All right, yeah, let's hope. But I've asked you some geometry stuff you guys didn't know when I taught it to you, so I don't know if it's going to help. But it was 2 years ago, so. All right, everybody good with this? All right, so do as many as you can. There's one with it looks like, here, I'll show you what it looks like, that you can skip. There might be a couple. I don't know how many there are. I don't have all the homework memorized. But you'll see something like this. Watch. You'll see a bracket, but like a double bracket. Okay, a lot of times they make it look like this. You see that? Kind of looks like a double bracket. This is the thing we haven't done yet. So if you see that on your homework, you can skip that one and we'll do that tomorrow, okay? But do everything else. So what is it? 11 to 22, all right? So this is section 1-7, page 49. So it's section 1-7. Page 49, and it's 11 to 22. So do all of them, except when you see this crazy looking thing right there. Don't worry about that. But you should be able to do everything else, I would think. All right? Everybody okay with that? All right. We'll see you then.